In this module, we'll see the basics of bash scripting. First one is the path. Whenever you write any command or execute any command in the Unix shell, it will look for a path, means where this binary for the command is located. The path variable contains the location where the Unix shell will look for the commands to be executed. To see what is the path, echo $path. It will see the entire path of the binaries available. The Unix shell will look for the binaries available under /user local bin or /user bin or /bin. Commands are not located in these directories, then it will be cannot be detected by the shell. Shell variables. Basically, variables are containers of values. A value to a variable in shell can be assigned by declaring the variable name equal to the value. There is no space on either side of the equal sign. There are two different types of variables available in Unix: shell variable and environment variables. Shell variables are available to current shell only. The environment variables are available to all the shells. Let's switch over to our terminal and declare some variable. To assign a variable, create a variable called var equal to abc. To print the value of the variable, write echo $var. Here you can see the value of the variable is printed. If you assign another value to the same variable, then that will be overridden. When you print echo $var again, it will be def. You can also assign a variable to another variable, like myvar equal to $var. When I print the new variable echo $myvar, it will print the value of var variable, that is def. Similarly, to print the environment variables, type the command print env. It will list all the environment variables assigned to my shell. So like my home directory, my username, my bash location, my shell, and different binary paths available to me. All those would be printed in the shell. Exporting a variable. Variables are seen within the shell itself. To make this variable to available to other shells or other scripts, we need to export those variables. To export a variable, type the command export var equal to abc echo $var. Now this variable var is available to all the shells or all the scripts. So any variable which is exported can be used even after the shell is logged out. That's all about variables. In the next lecture, we'll see comments, how you can add different type of comments in bash script. Comments. A comment is something which doesn't have any value in a script. It is used for explaining the code to fellow users. Let's create a shell script called comments.sh. In bash scripting, in order to add a single line comment, we have to start the line with hash. Anything written after hash will be considered as a comment. This is a hello world script. Save and execute it. You can see only the print statement is executed. The comment statement remains as it is in the script. In larger scripts, there could be more than one line of comments. We cannot add hash in front of each and every line which we want to comment. In order to add multiple line of comments, add colon, space, single quote, then add your comments. This is a hello world script with multiple lines of comments. That's all. Then in the end, let's print another statement called end. Let's save it and execute it. Here we see no comments are printed. We just see all the lines which we want to print are printed here and no comments are printed. So that's how you can add multiple line of comments in the bash script. So the last one in this topic is heredocs. What is the use of heredocs? Let's say you want to add some comments which you want to display on the output while executing the script. In that case, you can use heredocs. Switch to our terminal, open the same file comments.sh. To add heredocs, the statement would be cat >delim, then add your text here, multiple lines of text. then end the delim. The delim can be anything. It could be delim or it could be main text or anything. But one thing to remember, the start and end string should be same. So let's save it and execute it. Here we see our text is displayed on the prompt. So the usage of Redux could be documenting any kind of feature you want to display while executing a script. That's all about comments. In the next lecture, we'll see conditional statements. Like any other programming languages, conditional statements are used to evaluate different types of conditions in a script. There are different types of conditional statements like if else, or if. We'll also be looking at the different conditional operators like and or. So let's move into our terminal to check if conditions. Open a script called conditionals.sh, create a variable called num equal to 10, and start our if condition. If square bracket dollar num hyphen eq 10, then print statement echo match. To end the if statement, add 5. So let's understand the syntax. Always try to keep one space each side of the condition, otherwise it will give some weird error. Minus EQ operator is for comparison, and each if statement starts with a then. Inside the then you can add your conditional handling. Each and every if statement ends with 5. So let's execute the script. Conditionals. We can see our variable matches with 10, so the match is printed. Let's say we want another condition. Let's say we want to add another condition with an else statement. In order to add else statement, if $num add, in order to add else statement, else echo no match. Let's fail our condition by changing the number 11 and execute it. You can see the else statement is executed with no match is printed. Let's say we have more than one condition. We have more than two conditions. So let's change equal to operator to greater than operator. If $number is greater than 10, print greater. Another condition can be added using elif statement. $num less than 10, then print echo smaller. Then the final statement is matches. Let's save it and execute it. You can see first if condition is satisfied, so we are printing greater. Let's change the number to 5 and see if our elif condition is executed or not. Yes, our elif condition is executed. So in this way you can add multiple number of if else conditions in a script. Another type of conditional statements is created using AND operators and OR operators. AND operators can be written using ampersand. $num less than 5, let's say greater than 5, and less than 10, number is within our range. Then else statement number is out of range. Let's add our number at 6. You can see both the conditions are satisfied, so the number is within our range is printed. In order to execute this statement, both the conditions should be true. Let's move to the OR operator. The OR operator can be written as, so this statement, this number is within our range, will be executed if and only one of this condition is satisfied, since it is OR. If and only both the condition is false, then the else statement would be executed. 15. So 15 is neither greater than 5 nor less than 10. So our else statement should be executed. So let's add a number 4. 4 is neither greater than 5 nor less than 10. So let's change our conditions. Greater than 10 or less than 5. Here our number 6 is neither greater than 10 nor less than 5. When I execute, it will show number is out of range because neither of the conditions are satisfied by this number. So if both are false, then it will be evaluated to be false. So that's all about the conditional operators. In the next lecture, we'll look into different type of loops. Like any other programming language, we have different type of loops here, like for loop, while loop, until loop. We'll also see break and continue statements. So let's switch over to our terminal. Let's open the script called forloop.sh. The syntax for the for loop is for I in. We can define some range of numbers here. 1, 2, 3, 4, 5. Then a do statement. After that, we can print that loop using echo $i. Then it ends with done statement. Let's execute the script. You can see 1, 2, 3, 4, 5 is printed. So similar range can be provided using range operator like 1 dot dot 5. So it will print all the numbers within 4, 1 to 5. You can also add a sequence statement to print the loop in an incremental order, like let's print all the numbers between 1 to 10 with an increment of 2. To achieve this, we can add sequence operator like this way. Dollar within bracket will have sequence command 1, start from 1 with an increment of 2, and the end number is 10. Let's execute. You can see all the numbers between 1 to 10 is printed with an increment order of 2. Next is our while loop. Let's write a while loop. I equal to 0 while $i less than 10 do echo $i plus plus. Done. Let's execute the script. So it will print 0 to 10. There is another while loop called while true loop. In this case, in while true loop, we can create a loop which will be executing infinitely unless and until you provide an interrupt signal. So the condition would be true. While true, echo $i. So here you see the loop is being executed infinitely. Control C. This is all about while loop. Let's see until loop. Let's say until loop. The until loop is similar to while loop, but the difference is in until loop, it prints until the condition is true. So until, replace while with until, and rest of the syntax is same. That's all about the three fundamental loops in Bash. Let's discuss how we can use break and continue statements within the loop. Here we'll write a for loop with break statement. For I in 1 to 10, do, then are the if condition, if $i greater than 5, then break. And with 5 statements. So this means in the loop, while in the loop, if the value of I will be greater than 5, then the loop will be broken. So it will just print the values from 1 to 5. Let's execute. Yes, that's it. That's how you can use the break statement in the loop. Let's check continue. In case of continue, if the condition is met, it will come out of the loop. So let's write a continue statement inside our loop. For I in 1 to 10, do, our condition is if, let's check, if $i equal to 2 or $i equal to 5, then continue. And with 5 statement. If the value of $i is 2 and 5, then it will come out of the loop and the control goes to this for statement. So basically that means it will not print 2 and 5. The other things, the other values will be printed. Let's execute the script. Continue. So see here, only 1, 3, 4, 6, 7, 8, 9 is printed. 2 and 5 are excluded from the loop. That brings to the end of this loop section. So in the next lecture, we'll see string operations. In this lecture, we'll be looking into string processing. Let's create a new script called string_processing.sh. In this script, let's define a string and assign a value called hello world. In order to print the length of a string, the statement will be echo $#str. So the length of our string is 11. Next, we'll see how we can concatenate two strings. Let's say read two strings str1 and str2. The concatenation can be done by using the following statement, like new str equal to $str1 $str2. Okay, echo concatenated string is $new str. When you execute, it will ask for two inputs, hello world. So the new string is concatenated and it is printing hello world. Then let's try to compare two strings. So the strings can be compared using equal to operator. If str1 equal to $str2, then we'll print match, otherwise there would be no match. Let's execute the statement. String processing, let's give same text, hello hello. Here we see there's a match. Let's try to give a different input, hello world. There is no match. That's how you can compare two strings in Bash. That's all about string processing. In the next lecture, we'll see some more about numbers and arithmetics. Numbers and arithmetic. In this lecture, we'll see how we can do different arithmetic operations in bash scripting. Let's switch over to our terminal. Let's create two variables, num1 equal to 10, num2 equal to 2. In order to add two variables in cell, you can give statement like echo dollar num1 plus num2. Here we see two variables are added. Similarly, we can perform other arithmetic operations also. So here we are performing all the arithmetic operations like plus, minus, into, division and modules. Let's execute and see the results. So 10 plus 2 equal to 12, 10 minus 2 8, then 10 into 2 20, 10 by 5 2 5, and 10 module 2 is 0. In this way we can see all the results of arithmetic operations. We can also do the same kind of operations using EXPR expression statements. Echo $EXPR $num1 plus $num2. All the operations can be used in this way also. But in case of into operation, if you do not escape, it will throw an error. So in order to avoid that error, in case of multiplication operator, just add an escape before this. So let's execute and see the results. Number, arithmetic. All the similar things can be done using EXPR statements. That's all about the arithmetic operations. Let's see some hexadecimal operations. Let's see how we can convert a hexadecimal number into an integer. Here is our code. Read a hexadecimal number from the input, then we'll print like echo O base equal to 10 and I base is equal to 16. Then print $hex and pass the parameter to BC. BC is basically for calculating arithmetic things in bash. So it is basically a command available in Linux. We'll use this command or utility to convert the given input of hexadecimal to an integer value. Let's execute this. Numbers or arithmetics. Give hexadecimal input as FFFF. We see the hexadecimal number for FFFF is 65535. So our hexadecimal number is converted to an integer. That's all about the arithmetic operations in bash scripting. This brings to the closure of this module. Let's summarize what we have learned so far in this module. In this module, we have learned paths and variables, how we can add comments in bash scripting, then different type of conditional statements. Then we have learned different type of loops available in bash scripting. Finally, we learned something about string processing as well as numbers and arithmetic processing in bash scripting. That's all about this module. In the next module, we'll look at how we can perform standard IO in bash scripting.